All right, so now we're going to move on to Unit 3 and 4 test. Determine if the following pair of lines is parallel, perpendicular, or neither. So again, I'm going to remind you that some of these questions, I believe there was probably more multiple choice answers on some of these. There might be a little bit off, but the questions themselves are enough for you to prepare for your final, okay? So determine if the following pair of lines is parallel, perpendicular, or neither for this question. Well, all we need to do whenever we see parallel or perpendicular is always look at the slopes, right? So if slopes are parallel, then their slopes are equal. If slopes are perpendicular, then it's opposite reciprocal. And remember what that means. That means you're going to change the sign and you're going to flip it. Okay, so let's start by finding the slope of both of these lines. So for line 1, my slope is not necessarily there right away. So some of you might have put 3 as the answer. You got to do a little bit more work to get your slope on the first line. What you need to do is you need to get it in y equals mx plus b form. So here's my 3x minus 2y equals 10. And in order to get it in slope-intercept form, all I need to do is solve for y. So I'm going to go ahead and move my 3x over to the other side by subtracting 3x on both sides. And then I'm going to divide everything by negative 2. Every single item needs to be divided by negative 2. So right here with my x's, I have a negative 3 over a negative 2. That's a positive 3 over 2. And then 10 divided by negative 2, is a negative 5. So that's my new line. All I need for this question is to pull the slope from this line. So the slope is always what's attached to my my x, right? So I have y equals mx plus b. So my slope is going to be, for the first line, 3 over 2. For the second line, it's already in slope-intercept form, so I don't have to worry about doing any of this stuff on the right-hand side. All I have to do is use the slope-intercept formula, and whatever's attached to the x is my slope. So in this case, it's negative 2 over 3. So first of all, if these two lines were parallel, they would be the exact same number. So obviously, when I compare slope of line 1 to slope of line 2, they are not the same number, so it cannot be parallel. For perpendicular, they'd have to be the opposite signs. So the first slope is positive, the second is negative. That's opposite signs, so that's okay. And then the reciprocal part means that they need to be flipped. So my first slope is 3 over 2. My second slope is 2 over 3. So sure enough, they are perpendicular because they are opposite reciprocals to each other. So B was the correct answer on that one. Number 2 says, which equation is parallel to y equals negative 2x plus 2? Again, if I see parallel, perpendicular, any of that, right away a little buzzer should be going off in your head saying that you need to find the slope. This is already in slope-intercept form, so all I have to do is look at the number attached to the x, and that's my slope. I don't even need to worry about plugging it into point slope or anything. All I'm doing, all of these are in slope-intercept form. So all I'm doing is looking at the m's on each of my multiple choice answers. And I know that parallel lines have the same slope. So if my slope is negative 2 for this one, which line also has a slope of negative 2? And A is the only one that has the exact same slope. For number 3, which value of x will show that the lines for L and M are parallel? Well, if L and M are parallel, then all of those rules about corresponding angles, alternate interior, all that stuff has to be true. So in this case, what is 126 and 5x plus 6? These are corresponding angles that are located in the exact same location. They're both kind of in the top right. If you consider this almost like your intersection points, they're in the top, sorry, not top right, top left portion, right? So these two corresponding angles, which you need to know what that is, that's basically the same location. And corresponding angles are congruent. So which value of x is needed for this. Now remember, with these questions, you guys have two options. So you have a 50-50 chance of getting this question correct. You either add it up and set it equal to 180, or they're equal to each other. And look at them, okay? You can almost kind of guess that these two would be equal. If you have no clue what type of relationship they have, then look at the actual measurements of the angles. It's not the best way to go because they can always try to throw you off by the drawing. But if you're really not sure, you got to write something. So take your best guess. And in this case, they are equal to each other because they're corresponding angles. So I'm going to go ahead and solve for x by subtracting 6 and then dividing by 5. And I'm going to get that x equals 24. Don't forget, go back and reread your question. It does say which value of x. So x equaling 24 is what they want. I could always check my answer too. If I plugged in 24 to the 5x plus 6, it should equal 126. Okay. All right, number 4, which slope is perpendicular? So again, perpendicular slopes are opposite reciprocals, right? So opposite means it should be the opposite sign. So my initial slope is positive, so this slope has to be negative. So just knowing that, I can get rid of B and D. And then reciprocal means flip it. So if I have 5 over 8, then I should have 8 over 5. So that is my perpendicular slope. Number 5, you're given a statement and you're given angle measurements. So you just need to pay attention to the location of each of these letters. So this particular question is asking, what is the length of XZ? So X and Z happen to be the first and third letter. So I'm going to compare that to the first and third letter in my statement, which happens to be AC. So if I know I'm looking for XZ, it's the same exact distance as AC. So when I look at AC on my chart here, I have 11. So I do think this question was different on your guys' test, okay? So that's the question for XZ. I believe this was another question here, so it's 2 problems. What is the measurement of angle C? So you're still going to look at the original statement that they gave us. Triangle ABC is congruent to triangle XYZ. And look at where angle C is. C is the last letter, has to be equal to the first letter. So now I'm looking at my angle measurements over here, and angle C has to be equal to angle Z because they're both in the same location, right? They're the last letter in each statement. So since Z is 26, then angle C also has to be 26. Okay, for the next question, you're asked, what is the coordinate notation for the transformation used? For this particular question, you just got to go ahead and pick 2 points. It really doesn't matter which ones you pick. So I'm going to pick A, for example, and I'm going to find the point of A. So A happens to be -2, and my Y value is 4. And I'm going to compare that to M, because it looks like these are just reflected, right? Let's see. M is 2, +4. And I'm going to keep on going. Now I'm going to refer B. B happens to be -1, 1. And I'm going to refer that to N. N is 1, 1. And I could keep on going. Let's say if I look at C, C is the bottom one. That's the point -5, 1. I'm going to compare that to O. O looks like it's +5, 1. And last one is D, even though by this point you probably already see the pattern, but it never hurts to double check. It's -5, 4. And P is +5, 4. So what you're going to do is you're going to basically look for a pattern. So how am I getting from -2, 4 to +2, 4? Let's look at our x first. What is changing on my x value to get from -2 to +2? Look at them all the way down. Look at point B. My x is -1, then it's +1. Now the next one, -5, +5. negative 5, 5. So when you see if a pattern here, you should notice that each x value changes signs. So when you're changing signs, you're putting a negative in front of your x. So here's my original, and we are changing the sign on the x. Now let's go ahead and look at my y's. And just by knowing my x part, I can eliminate c and d already. Okay, now let's look at the y's. So I'm going to focus on only my y's. A is 4, M is 4. B is 1, N is 1. C is 1, O is 1. D is 4, P is 4. I don't see any changes happening to my y values. So my y is simply just going to stay the same. So now I look at my two translations that are left, and I know that my transformation that occurred has to be A. Okay, next one. What is the value of x? So basically, when I know that this is 80 degrees, am I using that they are supplementary or linear pair, or am I using that they're vertical angles? Because I see an x here. Well, in this case, since they're on the same side, they do create 180 degrees. So in order to find x, and again, remember my tips that I've told you guys about being careful about how you label things. I would label it an x. I'm going to solve for x by subtracting 80 on both sides, and I'm going to get 100. Number 8, in the figures, line M and N are parallel. Name all the angles that have the same measurement as angle 1. All right, so when I start with 1, I know that angle 3 is equal by vertical angles, right? I see an x and they're directly across from each other. I know that angle 5 is also congruent. That's because of corresponding angles. Make sure you guys know the definitions. I'm comparing them all to angle 1. And the last one, angle 7, also has to be equal to angle 1. And you could use a few theorems to do that one. For me, if I know angle 5 is equal, then I know angle 7 is by vertical angles. But if I'm wanting to compare angle 7 to angle 1, that would be by alternate exterior angles. Alternate meaning that you're hopping over that transversal line T, and you are staying exterior, which means outside of N and M. But you can use more than one reasoning for 7 to be correct as well. Okay, next one, lines R and S are parallel. So I'm going to go ahead and indicate that on my drawing. Which of these is a pair of alternate interior angles? Make sure you guys know all of those definitions. Alternate interior, alternate exterior, corresponding, vertical, and any of those other ones. I have them all labeled as part of your vocab. Okay? Alternate interior means in between these two. So I cannot pick 7, 8, 2, or 1. Those are all exterior angles. Alternate means I need to hop over my transversal line. Transversal is this one right here, right? The one splitting it in half. So ideas of alternate interior angles would be angle 4 and angle 6. Alternate means hop over the line. Interior means they're in between, or angle 3 and angle 5. So it looks like C and D were the correct answer for number 9. Those are alternate interior angles. Okay, number 10, which of these explains why angle 4 is congruent to angle 8? There's angle 4 and there's angle 8. This is what I mean. Vertical angles theorem looks like that. Alternate interior angles is between R and S. So I can give you an example. That would be like angle 3 and angle 5. We just did that. Corresponding angles is the exact same location. So when I'm looking at this set, I'm comparing it to this set. So 4 and 8 are the exact same location. Therefore, they are corresponding angles. Number 11, use this figure to answer, ignore that, okay? Line L is the perpendicular bisector of AB. So perpendicular bisector means that it creates a 90-degree angle, which they put here. And line L is the perpendicular bisector of AB. So this segment is equal to this segment. So it creates a 90-degree angle, and it also bisects the line, making them equal to each other. So the question is, what is AB? AB, meaning the entire line. Well, if AM is 6, and I know that AM is equal to BM, then BM is also 6. So the entire line from AB has to be 12, because 6 plus 6 is 12. Okay. Next one. The line can be described by the equation. Which of these is an equation of a line that is perpendicular to line A? I see perpendicular, so again, I need to look at the slope, right? Perpendicular is opposite, reciprocal. So all I need to do is focus in on my m. So my n is 3 over 5. So perpendicular to that would be change the sign, so it's going to be negative, and flip it to be 5 over 3. So my answer, all I'm doing is looking at my m's, which are attached to my x, and c is the only one that has that there. Okay, next one. I don't know why that moved with me, but it's all right. We can ignore it. Okay, next one. Find the length of the unknown side round to the nearest tenth. So this one's going to use Pythagorean theorem. It does not matter which side you put first, but it does matter where you put your hypotenuse. The hypotenuse is the one that it has to be equal to. So 12 squared is 144. 20 squared is 400. I'm going to subtract 144 on both sides. And let's see, 400 minus 144 is going to give me 256. Then I have to make sure I square root both sides. And the square root of 256 is going to be 16. So B is the correct answer. Last one. The length of two sides of a right triangle are leg 10 and hypotenuse 12. I'm not going to finish reading the problem because for me, if I'm using a right triangle, I'm going to draw it because most of us can think better with drawing, okay? So right triangle, 10 is going to be a leg. The hypotenuse is going to be 12. Find the third side. So again, we're going to use Pythagorean theorem. I'm going to go ahead and use x as my variable. And the only thing you have to make sure is that you put your hypotenuse, set it equal to that, okay? So then I have 100 plus x squared equals 144. I'm going to subtract 100 on both sides, and I'm going to get 44. Then I'm going to square root that. Now I'm not able to have the square root of 44, so this is when your review of radicals is important. So that would be 4 times 11, and 4 can be broken down to 2 times 2. And then I'm going to do my groups. So I have one group of 2's here, and my 11 is going to be left over. So 2 square root of 11 is the correct answer. That was for your unit 3 and 4 test.